Well, good afternoon, everyone. Welcome to our third boot camp session of the Run on Less Messy Middle series and the last session for the diesel and natural gas unit. My name is Rachel Ellenberger. I'm the Industry Engagement Manager for the North American Council for Freight Efficiency. If we can go to the next slide. As always, we would like to thank ACT News, who has put in a ton of work behind the scenes to make this series possible. If you are not already a subscriber, you can use the link that is linked out here through this slide to subscribe. Next slide, please. And another reminder that ACT is coming up soon, so make sure that you register ASAP. If you have not already, there is a promo code here that you can use to get a discounted registration. NACFE is going to send a couple of folks this year, and we do have a booth, number 6033, so make sure that you come by if you see us. Next slide, please. And as I mentioned, this is the third and final session of the diesel natural gas unit. In 2 weeks, we're going to be reconvening for our end of unit workshop. And this workshop will be 2 hours long. It's going to be hosted by our executive director, Mike Roth. And Mike will be bringing in some new faces to the conversation. Participants will be able to engage in breakout sessions. We'll be discussing more about what we heard during the unit sessions. When you receive the invitation from Stefan, which you should receive after this session, make sure that you not only accept the invitation, but make sure that you're also joining in time or on time in 2 weeks. Once we hit our limit for the limited number of folks we're able to accept, we're not able to have anybody else join. So make sure that you accept the invitation, make sure you join on time. Next slide, please. So before I turn it over to Mike for an update from the run, I just want to bring up to folks that NACFE published our Navigating the Messy Middle earlier this week. This white paper bill provides a finer definition of messy middle, what we mean when we say messy middle, and how fleets are going to be navigating the industry changes and challenges. So you can access both the new white paper and the 2023 report using the link on this slide that is going to be posted later this week. Next slide, please. And I'd like to turn it over to Mike with a quick update from the run.
Yeah, hello everybody. It's exciting. We're getting really ramping up with the run planning. Like Rachel said, we're in the middle of this boot camp series. I'd really encourage you to take the quizzes that'll follow this session. I took mine. We have some of our first swag. So we've got our Run on Less Messy Middle hats, and that'll be part of what you get if you pass all these quizzes. So I guess I already got mine, so I better pass all the quizzes, right, Rachel? Make sure I do. But also, the white paper is our explanation of what we mean by messy middle, and feels like we're definitely in it. I'm excited that we're doing this, decarbonizing or helping bring clarity to decarbonizing long haul. It's been a huge topic at the places I've been over the last few weeks, and as well, I'm here in Nashville at TMC, and it's exactly what everybody's talking about. So I'm very excited about all of this. And with announcing the paper that we published, we also announced yesterday that we will be having a press release on April 3rd to share what fleets will be operating which trucks and Run on Less Messy Middle in September. So really exciting times. 750 people registered today for this webinar. So very excited about everything around the run. So join us for that workshop in 2 weeks, and I'll see you out on the road somewhere, and then definitely as we get closer to the run. Thanks, Rachel.
Awesome. Thanks so much, Mike. So if we could go to the next slide, I'd just like to run through my normal housekeeping items before we get started with today's session. First, I would like to thank our session sponsor, Hexagon Agility. Thank you, Hexagon Agility, for your support to make this series possible. Next slide, please. As Mike had mentioned, the quiz will be available online immediately following this session. This is going to be your opportunity to test your knowledge from the session. And when you successfully complete the quiz, as Mike had mentioned, you'll have the opportunity to fill out a Google form, provide your contact information to be entered into that drawing for the Run on Less Messy Middle swag. So if Mike's hat wasn't incentive enough, we have a couple of exciting things there for you. So next slide, please. And a reminder that this session is being recorded. It's going to be available later this week, posted online. If you didn't get a chance to submit a question on the registration form and you would like to do so, please use the Q&A controls. They're located in the upper right-hand corner of your screen. During the Q&A, I will be relaying your questions to our speakers. And for those that we don't get to or won't be covering in this session, as I mentioned in our previous sessions, we will be collecting them to build out future content. So if there's something that you're curious about, something that you want to learn more about, make sure that you send in your questions. And finally, if you run into any technical issues, please be sure to reach out to Stephen Babcock at ACT News. His contact information is listed here, and he will help you troubleshoot. Next slide, please. And with that, we can go ahead and get started. I would like to introduce to you today our panel. We will first be hearing from Nick Pavlenko, who is the Fuels and Aviation Program Director for ICCT. Nick, thanks so much for joining us today. I will hand it over to you.
Great, thank you. So, hey everybody, it's a real pleasure to join you today. I'm the Aviation Fuel Program Director at ICCT, and I have a background in life cycle assessment and techno-economics of fuel. So I'm going to be speaking today about something very fundamental to kick off a few of the other presentations we have later on. So the basic question is, if you have different types of fuels, how are you going to differentiate between them? What methods and metrics are appropriate? And what are the key factors you want to pay attention to in your comparison? So the presentation today is going to be quite brief, but I hope I'll make the best use of that time to give you a crash course on some of the key issues and methods, and we can get into more detail in the Q&A if we have to. Next slide, please. So when looking at different powertrain and fuel combinations, what metric is the most important? I threw a whole bunch of them out here, but there's no right answer. It depends on the audience and the study in question. Depending on your priorities, you might value fuel economy, vehicle operation, or perhaps cost. And maybe if you're a policymaker, you're more interested in the tailpipe CO2 emissions or the total climate impact of a technology. So I was given the concept or the task of covering the concept of a well-to-wheel analysis for the presentation today. So I'm going to focus on the one at the bottom here, life cycle greenhouse gas emissions, which take into account the full life cycle of fuel production, all the way from raw material extraction down through final use in a vehicle. Next slide, please. So here is a really simplified flowchart of a biofuel's life cycle. And you can see several of the inputs necessary to assess the upstream emissions for a given biofuel. An LCA relies on collecting life cycle inventory data for each stage of a fuel's upstream production all the way through final consumption, pulling together data from things like farming, biorefineries, and filling in the gaps with model data where you can't actually collect it directly from the supply chain. And then there are models and tools which can consolidate that information and turn it into an impact assessment and give you something like a greenhouse gas estimate for a given fuel. So for example, the very well-known GREET LCA model allows users to input their own facility data or case-specific data into a broader model framework to come up with an estimate. If you could advance this slide, please. So in my example here, I focused on a default configuration for soy renewable diesel consumed in California using California's version of the GREET model. And as you can see, there's a variety of emissions components. There's farming, processing, distribution. An interesting wrinkle here, that cross-hatched bar at the top, is indirect land use change, which is an emission factor used in many regulatory analyses, which is an attempt to quantify the pressure that demand for cropland from policies can create in terms of greenhouse gas emissions. And here you can see how each component contributes and stacks up together to give you a sense of the total climate impact of the fuel, here presented in terms of CO2 equivalents per megajoule of fuel on the left-hand side. So this is about 60 grams per megajoule. As a baseline, fossil diesel is about 95 to 100. So about a 30 to 40% reduction. Next slide. So with that really basic framework for LCA in mind, here's a few different pathways all presented in terms of CO2 per megajoule of fuel supplied, with the baseline of California diesel emissions as the dotted horizontal line above. This is not total emissions, not total emissions for transport fuel in California. This is per megajoule of any given fuel. And you can see the greenhouse gas savings from each of the pathways varies quite considerably, even for a given type of fuel. For example, used cooking oil derived renewable diesel has about 1/3 the emissions of soy renewable diesel. Likewise, green hydrogen has about 80% lower emissions than gray hydrogen. And we can draw a few trends from this. Generally, fossil fuel derived pathways have higher emissions, waste and residues have lower emissions, and for natural gas pathways, emissions can be very sensitive to upstream methane leakage assumptions. And digging into hydrogen a bit more in detail, you can see that there's extra emissions associated with processing natural gas into gray hydrogen. Though hydrogen is zero emission at the point of use, it nevertheless inherits whatever upstream emissions are attributable to the feedstock used to make it. So things like energy use, methane leakage, and so on. Even if it's zero combustion emissions, it still has life cycle emissions. And you can reduce the life cycle emissions of hydrogen through things like carbon capture in the case of fossil hydrogen, or by sourcing renewable electricity if you're making electrolysis derived hydrogen. Next slide, please. So a key issue that comes out in an LCA is that conversion losses across the supply chain can compound and generate higher emissions. This includes conversion losses to produce fuel, as well as the efficiency of the final powertrain. So let's start thinking about grid electricity and what that means when you start turning into different fuels. So if you have grid average electricity in California, if you use it in an EV, you can generate fairly steep greenhouse gas savings versus diesel, like 80%. But if you convert into hydrogen, you're losing a fair share in conversion, as you can see there, and then you're losing energy again in the vehicle cycle. So your total well-to-wheel efficiency is a lot lower than a case where there's fewer conversion steps. Now, if you take an extra step and you convert hydrogen into a synthetic diesel fuel, you're losing additional energy during fuel conversion, and then you're combusting it in a less efficient internal combustion engine. And this adds up. Advance the slide, please. Here's what it looks like in terms of emissions, and advance it one more time. Though you start out with the same emissions for the electricity, you're adding extra steps, you're losing energy at each stage of the process. You're starting with something with an emission factor of around 80, you're going up to 120 or so, turning into hydrogen, and then around 160 or so, turning into synthetic diesel. Starting from the same original source of energy, you're generating a more emissions-intensive fuel. Next slide, please. So let's try and put this all together. Now that we have an understanding of the fuel cycle, let's also combine it with the vehicle cycle and try and compare emissions on a consistent basis. While 1 megajoule of electricity, hydrogen, or liquid fuel, they all have the same energy content, the vehicle powertrains have different efficiencies. So an electric motor will generate more kilometers of vehicle travel than an internal combustion engine, and a fuel cell will get somewhere in between. Therefore, the most important metric for the purposes of this specific comparison may be emissions per kilometer, but you can go even deeper and say a preferable metric might be emissions per trip or emissions per ton kilometer of cargo or another service provided. And so on this slide from left to right, we have the fuel cycle emissions upstream and downstream for a variety of vehicle and powertrain combinations. For the sake of internal consistency, this is from an EU study that has vehicle efficiencies for that market, though the broad trends apply across regions. And you can see that the battery powertrain running on 100% renewable electricity offers the lowest emissions per kilometer. Of course, fossil diesel is higher. And you see a trend here that if you take a high emission source of fuel, let's say gray hydrogen, and you combust it relatively inefficiently, say hydrogen ice, you may be generating more emissions on net. You can see that hydrogen ice example on the right is ahead of the fossil diesel and generates more emissions per kilometer. Next slide, please. I think that takes us to the end of the presentation. Happy to get into more details and talk at the Q&A. Thanks.
And thank you so much, Nick. And I just want to let everybody know as well. Nick provided some great resources that you can read. Look at when you go back to the session page on runonless.com. Nick provided a report that I'd like to draw everybody's attention to, as well as a couple of appendices in his slides as well, which you guys can explore when you look at these slides after they're uploaded later this week. So Nick, thank you so much for your presentation, and I'll bring you back for the Q&A. Next up, we have Jerome McCarville, who is the Manager of National Accounts for Chevron Renewable Energy Group. Jerome, thank you so much for joining us, and I will hand it over to you.
Yeah, well, thanks, Rachel. It's a pleasure to be here. So I'm Jerome McCarville. I'm the Manager of National Accounts at Renewable Energy Group, mainly focusing on our direct end-use customers' fleets. Next slide, please. This is just our cautionary statement. Next slide, please. So this slide kind of shows you what Chevron Renewable Energy Group is all about. In the dark blue boxes, that's our production facilities where we're actually making either a biodiesel or renewable diesel. The lighter blue is where we have offices across the US and Europe. So we have like about 43 terminals that were put back to the previous slide. There you go. We have about 43 terminals that we're putting our biofuels through from those 9 active biorefineries. We're delivered to 41 states, 3 Canadian provinces, and 6 countries. So now you can go to the next slide. So I apologize for not having 2024 numbers. Couldn't get those updated for public consumption prior to this, but this is 2023. And with this top left box, we had about 420 million gallons of production between our 9 refineries. That is 8 biodiesel production facilities and 1 renewable diesel production that I'll talk a little bit more detail here in a few minutes. The top right box shows the number of 708, and people get confused when they say, how can that be 708 when we're only producing 420? Well, Chevron Renewable Energy Group actually goes out in the marketplace and procures other third-party biofuels if they meet the high quality specifications. So we're actually constantly in the marketplace looking to buy offtakes from other producers and then marketing those as Chevron Renewable Energy gallons. So we're actually gives us a good indication too of kind of what's going on in the marketplace from a quality standpoint as well. We have 10 terminals in California, 39 terminals across the US that we're putting those gallons through. Kind of a snapshot, that means about 50,000 truckloads a year, 180 water movements, and about 7,500 rail cars to move those products. None of the biofuels are moved through the pipeline, so we have to move that via truck, rail, water, or rail. Next slide, please. I know the slide was touched on in the first run from the Clean Fuels, I think Scott Fenwick, but this kind of shows you where the fuels go and why they go there. So you go back to the, don't go back to the slide, but back to the slide of our production facilities. That kind of mirrors to these slides where the state incentives are. So these are states that either have, there's a couple that have mandates for fuels, Minnesota and Pennsylvania, and then the other states have some type of financial incentive to blend a biofuel or renewable diesel. And then the West Coast has the LCFS markets. So it shows you really why these fuels are being drawn to these states. That doesn't say that fuels are sold in other states, but they don't have the financial incentives. So we have to make sure that we optimize our opportunity to create the highest value for these fuels, and that's why they go to these markets. Next slide, please. This slide shows you states that have policies to enable biodiesel blend in their own fleet. So it kind of mirrors the previous slide, but it's a little different, and it shows you what the blend levels are that the states have put in place. Next slide. got a couple slides here about the benefits of biodiesel and renewable diesel. Benefits of biodiesel, it's an oxygenated fuel. It allows it to burn and combust a lot cleaner. That helps with the after treatment DPF system, reducing the amount of soot that's put through that system. Also, one of the big benefits of biodiesel is the enhanced lubricity. So a 2% blend of biodiesel will create more lubricity in traditional ultra low sulfur fuel than a lubricity additive. So it has lower engine emissions, non-toxic, non-hazardous, and it's highly blendable in today's petroleum fuels. Next slide, please. Benefits of renewable diesel: high quality drop-in fuel, can be consumed, transferred into at a R99 100%. Has ultra high cetane, desirable cloud point. Like I said, highly blendable, and also has lower emissions. And actually, one of the things about the renewable diesel, it's a paraffinic fuel, which is very, very similar to the chemical makeup of petroleum diesel. Next slide, please. The benefits of biodiesel and renewable diesel are synergistic. Carbon intensity scores are lower than petroleum diesel. BD RD blends, which we were the first marketer and producer to put that into the California market with an R80 B20 product. And that has lower freezing points with the benefits of the two. And we believe it's the superior fuel to R99 because of one of the main reasons is the added lubricity as well. The BD RD blends can provide one of the lowest overall engine emissions of any diesel fuel option today. And we just believe it's a very strong product out in the marketplace. Next slide, please. This is our renewable diesel facility in Geismar, Louisiana. It's the single renewable diesel facility that we have. The other 8 are biodiesel, as I mentioned. That is currently a 90 million gallon production facility that has been going through an expansion the last couple of years, and it's actually in commissioning right now to almost quadruple to become a 340 million gallon production facility of renewable diesel. We're also adding enhanced marine logistics that'll help us move the product to the markets where it'll be consumed. And we're actually, like I said, we're actually commissioning that here in Q1 of 2025. Next slide, please. This is kind of a current history growth chart of renewable fuels and what we think will continue. So the last several years have seen significant growth in the biofuels industry, specifically in the renewable diesel space. As I just mentioned, we're going from 90 to 340 million gallons at that facility. But if you look at the graph going forward in the orange bars, that shows the future, what we believe the future is for renewable diesel production. But there will consistently be a continued demand for biodiesel as well. And it's an exciting market, and we're continuing to watch policy as we think there will be more opportunities for markets to develop to have some incentives for these fuels. Next slide, please. Like I said, the biodiesel industry has continued to grow. Just reached a record of 5 billion gallons of consumption in 2024. So we think that'll continue to grow significantly and help offer lower carbon transportation solutions out there. Next slide, please. I did want to mention that Chevron Renewable Energy Group has a network of CNG stations. This just is a simple map. Our next guest is going to talk a little bit more about the CNG, but we also have the opportunity to have lower carbon CNG at retail locations across the marketplace. And Rachel, I'll turn it back to you.
Great. Thank you so much, Jerome. And I do want to elevate what Jerome said next. Our next speaker is going to talk about very similar, but for CNG and RNG. So I would like to welcome Derek Turbide, who is the Vice President of Business Development for Clean Energy. Thank you so much, Derek, for being here. I will hand it over to you for your presentation.
Thank you, Rachel Nakfi, and everyone joining us today. My presentation is going to focus on RNG for heavy-duty trucking, specifically infrastructure, pricing, and availability. First slide, please. Our agenda, we'll touch quickly on RNG production, and we'll get into the distribution of RNG a bit. And then, of course, the infrastructure, pricing, and the multitude of resources that are available for fleets considering introducing RNG into their fleet. Next slide, please. Before we get too far, I just want to give a quick intro on Clean Energy. Clean Energy is an RNG producer and distributor with over 25 years of experience. We own and operate dairy farm RNG plants and have other source supply contracts to support our goal of delivering 100% RNG to our network of 600 clean energy and customer-owned stations across North America. Next slide, please. So what is renewable natural gas? Well, it's chemically the same natural gas we use to heat, cool, and cook in our homes if we have natural gas utility service. The difference is the source. RNG is made when organic matter decays, and the resulting gas is collected and purified into a renewable transportation fuel. Next slide, please. The most common sources of RNG are landfills, wastewater treatment plants, and livestock farms. Landfills produce the most RNG, while dairy farms are the primary source of livestock RNG. Next slide, please. How is RNG made? Well, this illustration shows how we use dairy farm manure to make RNG. Manure is consolidated, collected, and put into a digester. In the digester, anaerobic digestion occurs. Methane and other gases are the byproduct. This trapped gas is then moved via a system of pipes, blowers, and compressors to a gas cleanup skid where it's brought up to the local natural gas utilities pipeline quality standards. Now, it's RNG, and it can be injected into the local pipeline, transported, and sold at our network of stations across North America through book and claim accounting, just like renewable electricity can. Next slide. As you can see on the map to the left, RNG can be moved over a series of interconnected pipelines. Altogether, the US has over 2.5 million miles of natural gas pipeline. On the right side, you can see the Department of Energy's alternative fuel station locator and the 1,500 natural gas fueling stations that are across North America. Clean Energy's network of public natural gas fueling stations can be found at the link on the right. We have about 300 and growing public natural gas stations. Next slide. This is a Clean Energy station with a public side and a private side. We built a network of stations like this across the country for one of our customers. The unique thing about this one is that it offers both private time fill fueling and public fast fill fueling, which we'll cover in the next few slides. Next slide, please. All public stations are fast fill stations. These stations offer fuel rates and features like the diesel fueling experience. However, they aren't on every corner yet. Some were not designed for heavy-duty vehicle fueling, so they might be a little slower, and fuel tank capacity is limited to about 85%. But that 85% still equates to over 700 miles of range between fills on a standard RNG fueled tractor. In fact, spec'd with the max fuel capacity, an RNG fueled tractor can have 1,000+ mile range. Next slide, please. Time fill is typically a private or backlot fueling solution, and it works well when you have vehicles that park for 4 hours or more daily. As you can see, with time fill, we are fueling many vehicles at once over a longer period of time, so there's less heat buildup, which leads to fuller vehicle fills. This setup works really well for return to base operations, looking to minimize labor associated with fueling vehicles daily. Next slide. Now here's how the station works. Remember, our RNG is flowing around the country in the natural gas pipeline system. We tap into that pipeline at the local level and pull our gas out at the station. You can see the gas meter there in the lower right corner. The gas flows from there at low pressure into a natural gas dryer, which removes any possible moisture that might be in the gas before it's compressed by the electric powered reciprocating compressors inside those stainless steel boxes. Each box has 2 compressors, and there's room for more at the facility, as you can see. This is a large facility by most standards, and this equipment can feed both the public side of that picture we looked at earlier, as well as the private side. Once the gas is compressed to a high pressure, it's ready to go directly into vehicles or into the white storage tubes between the compressors and the fueling lanes in the picture. Next slide. Here are some basics if you ever want to have your own station. As you can see, you don't need too much space to get started, but you do need to locate the equipment 10 feet off property lines and not directly under power lines. The closer you are to the natural gas pipeline, which will be found in the street, and the higher the local pipeline pressure, the lower the cost of your project. Having 600 stations in 42 states and Canada, we maintain relationships with gas utilities throughout North America and are often helping fleets investigate the utilities as a first step to considering on-site fueling. Next slide, please. On average, fleet customers are paying about $2 a gallon at natural gas fueling stations. If a customer owns their station, they may pay less depending on how they look at their investment and cost buildup. There are also credits available for RNG used as a transportation fuel, RINs at the federal level, and low carbon fuel credits in several states. Historically, we've had a 50-cent per gallon federal rebate, and there's a proposed bill for $1 per gallon rebate if a station uses RNG. In most cases, the station equipment owner directly or indirectly holds the keys to these credits. Next slide, please. There are incentives and grants available for RNG fueled tractors as well. Clean Energy offers a $10,000 discount for clean energy customers that purchase PACCAR natural gas trucks or tractors. Grants are available in many states, and Clean Energy will also provide up to $50,000 towards natural gas vehicles that can fuel at our California stations where our economics are the strongest. Next slide, please. If you want to try it before you buy it, we have you covered. This is our demo truck that we allow fleets to plate and use for a 2-week period. It's in California now and will be moving its way into Arizona and Texas over the next few months, and it will continue going east and northeast. Next slide. We found over the years that training is the best way to ensure a successful natural gas fleet rollout. So we developed a natural gas vehicle safety and maintenance training program with our friends at the Alternative Fuel Vehicle Institute. We also have staff trainers that are always available for our existing customers. Next slide, please. These are just some of our partners. For every name brand on here, there are several smaller regional fleets that are having success with natural gas vehicles. While some of these fleets like WM and UPS have thousands of natural gas vehicles and hundreds of their own stations combined, the majority of these fleets are just getting started as they see RNG offers a clean, competitive, and cost-effective alternative fuel solution with the right horsepower, torque, and range in the Cummins X15 natural gas engine released last year. Next slide, please. This final slide highlights several key areas we've discussed today and others where we support our customers in their RNG fueling journeys. There's a lot of moving parts, and fleets can benefit from good partners that offer a turnkey solution and collaborative approach. We aim to do that with every customer, large or small, and have a team of over 500 professionals to support that mission. Next slide, please. Thank you for your time in joining us today. I really look forward to your questions, or if you prefer to follow up later, here's my contact information. Thank you, Rachel.
Thanks so much, Derek. That was great. And for those of you who didn't catch the current customer slide, I'm really excited to introduce our next speaker, Ryan, with UPS. But you'll also recognize that we had Paper Transport and WM on 2 weeks ago, which was great. So if you didn't catch our last session, be sure that you log in to watch the recording. So Ryan, I will turn it over to you for to round us out for this session here. Ryan is the Global Director of Automotive Sustainability for UPS. Ryan, the floor is yours.
Hey, thanks, Rachel. And wow, this is a great killer's row of speakers. You know, as a sustainability professional, the three speakers that were ahead of me, you know, you have life cycle analysis, you got biofuels with Chevron, you have infrastructure and RNG with clean fuels, and now you have fleet, right? Those are the four legs of any stool when you have to consider what is our sustainable solutions, what is the future of our fleet, right? And everybody's here on this call. So with that, my name is Ryan Bankert. I'm the Global Director of Sustainability for UPS. I'm responsible for decarbonizing our ground fleet, as well as the ground support equipment that take care of our airlines. And we've been in this business of deploying sustainable and advanced technology vehicles for over 90 years. Stefan, can I get the next slide? Next slide, Stefan. Yeah, there we go. So what are our guiding principles at UPS, right, when it comes to sustainability? This year, 40% alt fuel usage in our ground operations, RNG and biofuels with our two previous speakers are a big part of that. 25% renewable electricity powering our facilities and also supporting our EV deployments. If you move towards 2035, you have 30% sustainable aviation fuel. And, you know, a good question for Jerome is going to be how are biofuels like biodiesel and renewable diesel going to be impacted with the pressure from sustainable aviation fuel that's becoming in such high demand. 100% renewable electricity powering our facilities in 2035. And then finally, the one goal I'm most proud of, 50% reduction in CO2 per package delivered off our 2020 baseline. Why I'm proud of that is because we already had a lot of alternative fuel vehicles deployed in 2020, and we gave ourselves a very aggressive goal. Next slide, Stefan. So what does our fleet look like globally? Well, 19,000 advanced technology vehicles on the road, advanced technology and alternative fuel. And I always say it's everything from human power to hydrogen. And that's what we have on the road today. Compressed natural gas, liquid natural gas, LNG, hybrid electric, propane, electric bikes. Every low carbon solution, every advanced technology solution has a seat at our table when it comes to existing in our rolling laboratory. So why is the rolling laboratory important? Well, when you're a fleet, you have to look at what's the right solution for my particular duty cycle, delivery cycle, maintenance cycle, whatever it is. And our rolling laboratory has given us unique insight into a lot of these areas, as well as the emission produced by these technologies. And that's where, Nick's early comments are very important, because as a fleet today, you have to look at what are my life cycle analysis and how do I benefit, how do I weigh that benefit of emission reduction with TCO and costs associated with infrastructure deployment. All of that is evaluated in our rolling laboratory. And UPS is one of those companies that our efforts benefit everybody in the industry, all fleets, large and small. Stefan, next slide. So here is an example when we're talking about infrastructure of a near zero building, right? So I don't think we can say zero anymore. That's why I put near zero on there, because as Stefan alluded to early on, with any technology chosen and the particular life cycle analysis, there's usually emissions associated with it. You know, when you saw that compressed natural gas on a fossil level had roughly the same footprint as electricity, and when it comes to life cycle carbon emissions, if you use the California grid. Now, if you use solar, you can get down to some of these lower levels, but we always say, you know, near zero. So why is the building an important aspect to the fleet? Well, as we begin to deploy or grow into our new buildings, we're considering renovations, we have to look at what is the fuel of the future, right? The FOF. And we might say, well, let's make this a building of the future. Let's make this a near zero building, but what's the fuel of the future? And in doing so, you want to make sure that there are certain elements that you've worked with your utility, have in consideration. Derek mentioned with CNG, is there a pipeline nearby? You know, what's the yard look like? Can it accommodate this extra infrastructure? Does it have the power for a CNG station? When you look at battery electric vehicles, does this have the capacity? Does the utility have the capacity nearby? Am I going to be putting a substation in there? Is there one that already exists there? These are conversations you can have early on when you're talking about, as a fleet, how do we have to overlay our infrastructure decisions, which will affect TCO? How long will I have to run this fleet to pay off some of these infrastructure enhancements? And we all know that early on in a building process, when these decisions are made, it's usually the most cost beneficial time to make that decision, as opposed to adding it later. Next slide, Stefan. So as Clean Energy referred to, this is our time fill. It's the most efficient way to fuel, and that's at that near zero building that's in California. And time fill, more fuel in the tanks. You know, your vehicles, if they're going to be sitting during the day, it's great. You still should always have a fast fill station so that you can slip seat the equipment and make sure that you can fuel on the turn, so you can put CNG tractors at extended locations. But this is an example of our CNG slow fill. And what makes it a near zero building, you know, if you're saying, well, why is it near zero if you have natural gas there? It's near zero because we contract for 100% renewable natural gas, and our preferred natural gas in California is negative 200 CI score dairy gas, right? So in those processes, they help support the agricultural and farmers, and then obviously that supports the economy with ensuring that the methane emissions are managed properly. So with that, in summary, and I want to move quickly into the questions, because I even have questions for some of the folks that spoke before me, but UPS is committed to being carbon neutral by 2050, and we continue to grow our industry-leading and advanced technology alternative fuel fleet. I always encourage folks, especially small fleets, take advantage of what we've put out through our rolling laboratory and the enhancements that we've made with our OEM partners. Hexagon Agility, one that's sponsoring the call today. But when you're shipping with UPS, you're actually benefiting all fleets, large and small, when it comes to our purpose of advancing these low carbon sustainable technologies. And by that, we adopted the all the above approach to these solutions. We don't just pick one winner, as we've seen out there today, or with regulation was suggesting that there might be one winner. We look at them all and really evaluate them on their own individual merits through our rolling laboratory, and take into consideration the infrastructure constraints. And that's that energy agnostic approach. And then finally, before I pass it back to Rachel and we move into questions, from trash to transportation fuel, biomethane. I can't say right now what a great solution. It's very elegant. I can't say it enough. What an elegant solution RNG and biomethane is. Methane is 80 times more potent at warming the atmosphere than carbon, and RNG, takes that from what would be a anthropogenic waste stream and turns it into a transportation fuel that benefits everybody. Next slide, Stefan. So at the beginning, I said we've been doing this for 90 years roughly. And I want to show folks, we deployed our first electric vehicles here in California and Los Angeles in 1936. There was mechanics and carpenters that worked on these vehicles back then. So we've been at this for a long time. We have a lot of experience in the space. And when I say that it's a four-legged stool where you have the emissions, the fuels, the infrastructure, and then the vehicles and fleets, very much is for those that are making that decision-making process. With that, that concludes my presentation, and I think we can move to questions. Rachel, pass it back to you.
Absolutely. Thanks so much, Ryan, for rounding us out here. If I could have all of our speakers come back, we'll go ahead and get into the question and answer section. And Ryan, I'm glad that you had mentioned you have questions, because I was also thinking about questions as we were going through. I have a couple from the audience as well that I want to make sure that we get to. But I guess I'll just kind of move in chronological order of the order we heard presentations. So Nick, my first one is for you. This is from the audience. So talking about an LCA. So if renewable diesel production is shifting soy oils from the food sector, which could then be backfilled with something more GHG intensive like palm oil, is the real impact underestimated? Or do you see those types of limitations in your LCA calculations?
Yeah, that's a great question. I alluded to that issue a little bit, but that could easily be a presentation or maybe a series of presentations on its own. And so the short answer is that this is definitely something that is on the radar of the scientific community, of policymakers and regulators. But it is a complex problem, and you need to use economic models to even begin to answer this. So oftentimes, if you're doing an LCA of a biofuel, you're running an economic model to understand the indirect land use change emissions, the market response to shifting cropland to supporting biofuels away from other existing uses. Now, it's not always going to be one-to-one, and that's why you need to use a model, because the market responds in a lot of ways. You can increase yield, you can multi-crop on a given plot of cropland, you can reduce demand from other industries, and all of that is going to affect the final LCA emission for a given fuel.
Gotcha. Yeah, I think it's when you're doing any of these calculations, it's a lot of what ifs, and then how does that work for the math? So I can definitely understand that. Another question that I would have is, have you seen the well-to-wheels considerations, the LCA considerations, become more popular of a topic as the industry progresses? Or do you think it's been pretty consistently top of mind for folks? I've been in the industry for only 6 years, but when I first started, a lot of folks, we were just talking about tailpipe, and that may have been where I kind of was in the industry at the time. But do you see it becoming a more popular consideration as fuels are switching?
Yes, definitely. I would attribute a large portion of the shift to the salience of the West Coast low carbon fuel standards. Traditionally, fuels policies were providing incentives for every gallon of production, or provided support if you met a certain threshold. But the shift to a GHG intensity framework, like in California's policy, for example, creates a value and incentive for each incremental greenhouse gas reduction, and therefore there's a lot more incentive to incentivize and support some of the lower carbon fuels and improve the GHG intensity of existing fuels.
Mm-hmm. I see. So I'd like to move on to Jerome, to your presentation. So we have one of the questions from our audience is, are there any challenges in 2025 with sourcing bio additives for biodiesel? Do they pose a threat to food crops, or is that an outdated myth?
That question might be a little bit out of my pay grade. I can certainly get an answer a little bit more detailed from our technical team. But from my understanding, there's not really a good additive market out there for biofuels. I don't know if they're talking specifically biodiesel or renewable diesel, and what type of additive they're looking for. A lot of times we hear folks looking for like a cold flow improver in renewable diesel, and from my knowledge, that's not available. So, but
Mhm.
if they want to submit that question, I can definitely do a follow up and get a more detailed answer for that.
Gotcha. And my next question, this is something that we actually talked about in our first session when our friends over at Clean Fuels Alliance America were joining us. And Ryan, I think that you actually alluded to it in your section as well. But for Jerome, so as we are seeing increased renewable diesel production, do you think that some of this is going to displace biodiesel, or will it just add to the demand? Do you foresee the demand from other industries like aviation threatening the availability of this fuel for trucking?
So we think it's just going to add to it. We don't
Mhm.
think it's really going to impact biodiesel production a whole lot. As on that slide, it might drop off a little bit. The biggest thing that's going to impact the production going forward from biodiesel, renewable diesel, or sustainable aviation fuel is really what the market puts in place for incentives to make the fuel affordable to the public.
Mhm.
So until we have a clearer picture on that, it's really hard to say what's going to happen there. There's actually a lot of uncertainty, the most uncertainty that the industry's seen for a very, very long time currently in the biofuels and renewable fuels space due to some federal tax credits that ended in December 31st, 2024, that the definitions have not been finalized yet going forward. So between the changes of administration, so a lot of current uncertainty as well, just currently, but going forward, it's just going to be based on kind of what the incentives are out there for the different fuels.
Yeah, I think that makes a lot of sense. So at its core, this is it is an infrastructure session, and I want to talk a little bit about how CNG, RNG, and our diesel derivatives here, how it translates into the infrastructure topic. One of the arguments for CNG, RNG, renewable biodiesel is that it can capitalize on existing infrastructure. It doesn't need a build out of expensive and intensive infrastructure. So for Jerome and for Derek as well, can you speak a little bit more to this and about how utilizing existing infrastructure, how does that impact the uptime of fleets that are looking to make these changes?
So I could speak to it if you'd like first.
Yeah, go ahead, Derek.
Right. So there's a pretty good network of natural gas fueling stations out there between Clean Energy and other companies like Clean Energy, and it's growing every year with new fleets coming online and new lanes that need to be run in trucking. The market and industry will take care of that issue. So while it's not perfect today, like I said, it's not on every corner. The majority of the country is covered, and we'll grow with it as it continues.
Yeah,
Yeah.
one of the things I would add real quickly is we've seen here for the first time in Q1 of this year where a national retailer is actually offering a B99 dispensing island at their retail location. So as the demand for higher blends of biodiesel are being implemented in the marketplace, we're actually seeing where the retail market is starting to adjust and offer that higher blend option.
Okay. So my next question is from the audience here. So somebody is curious, for CNG and RNG fueling, are there any alternatives besides either building a station or using that public infrastructure, or are those kind of the two that we're looking at?
Sure. We often get asked if there's some sort of a wet hosing option.
Mhm.
So in order to maximize, the economics of CNG, it really works well to fuel at that public station or build your own if your fleet is sizable enough to make that happen. And typically you're looking at, let's call it 20 or so vehicles that return to base. You could start to pencil those economics on having your own infrastructure. As far as the wet hosing goes, there are options where you can fill large tube trailers at public stations or even private stations and transport that gas and with some other equipment have a wet hosing type operation on site. It's not the most cost-effective way to do natural gas fueling, but it can be done. And then there are also portable compressor options. But when you have a portable compressor, you're going to need some sort of access to natural gas, whether it be with tube trailers or local access to your pipeline. So it's a little more complicated, but it can be done, and it is being done today.
Gotcha. Okay, great. So Ryan, I want to pass it over to you. I thought that part of the part of your presentation, we were talking about the UPS rolling laboratory. I thought was really cool. Is there more information that you can share with us? Number one, about the rolling laboratory, and then how UPS kind of shares and packages that information, what you guys learned through your operations, so that the rest of the industry can benefit.
Sure. Yeah. So, and I just want to add to what Derek was saying about CNG infrastructure and the smaller stations, is that when fleets are looking at what fuels to pick, usually if you have a smaller fleet, the renewable diesel drop-in seems to be the quickest and easiest and least TCO. When you start getting into station requirements, and whether it's virtual pipeline or small stations, and talking with Derek, he can give you a lot of these solutions. The math begins to pencil out very quickly with the more gallons you use. So keep that in mind. If you make an investment in a CNG station, and it's something that as you grow, you're going to actually see a better TCO and more cost benefit back into your operations. And so I'll say that, and then pivot to the rolling laboratory. So one of our four founding fathers, Charlie Soderstrom at UPS, he moved us from basically bicycle delivery service into the automotives with the Model T. And that was our first kind of opportunity to reevaluate the modes of transportation. And then from there, we, in 1936, moved into some electric solutions. And what we found at that time was that electric and gasoline were very much had a lot of parity as far as efficiency goes. And it's interesting to see those old handwritten notes on electric vehicles in 1936. So how the rolling laboratory benefits the industry, large and small, is we work with providers. We work with Clean Energy, as they've said on their slide before. We work with Cummins. We work with Hexagon Agility. We work with CARB and the DOE, and we evaluate all these different technologies in real world applications. Some of our current projects are wireless charging technology, and we have some of those with the Spire network. We've had hydrogen deployments in California with Toyota, Kenworth, Linamar, Roush, those folks, and CARB, where we tested the California hydrogen infrastructure as well as the vehicle utilization. And all of that data is publicly available because these were publicly funded tests through the DOE or CARB websites. And that's where that data then goes to benefit the industry as a whole. We are on our 5th generation Cummins engine with the 15 liter that we're very excited about. Got some great data that's coming out of those tests currently. And if you go back with the relationship with Cummins, we've been working with Cummins since the 9 liter, and for over 30 years, helping them develop those different vehicles or engine platforms. And then we worked with Ford, we've worked with Freightliner, all these other OEMs to help improve those fleets. So that's a little bit of how the rolling laboratory works and where that information can be found.
I think that's awesome. And I was just noting the clock. I think we have to wrap up here, even though I feel like we could talk about this for quite some time. I just want to thank you guys so much for joining us today for our 3rd bootcamp session. Thank you, speakers, for providing your expertise and your information here. We want to welcome everybody back for our 1st unit workshop 2 weeks from today. So make sure that you tune in then. Remember, you can go back to the landing page of this session on runonless.com to take the quiz, and make sure that you accept the invitation from Stefan when you see it come through. Stefan, if we could advance to our last slide here, you'll see our handles on social media. We have linked out here. Feel free to connect with us. We love to interact with everybody. We appreciate all the time that you've all spent with us this afternoon. Have a wonderful day, and we will hopefully see you in 2 weeks.